As the sheer scale of AI deployments grows, the monolithic single model block is fracturing into specialized structural pillars. Building a product in 2026 requires more than a thin interface over a single endpoint. Production systems now have to handle rate limits, compliance audits, and multi-agent loops that often break simple, non-modular setups. For engineering leaders, this shift brings a specific kind of friction. You are often forced to choose between integration delays that stall your roadmap and API costs that scale faster than your user base. Managing these pressures requires isolating the four components of the 2026 stack: the deployment layer, the routing layer, the intelligence layer, and the action layer. Defining these four layers as separate modules allows teams to update their models or their infrastructure without rebuilding the entire application. The deployment layer is the hardware foundational, the specific environment where your chosen models actually execute. Using managed cloud APIs provides a way to access frontier models immediately. You send a request and receive a response, with the provider handling all hardware maintenance and scaling in the background. This quadrant chart maps that speed against long-term control. Cloud APIs fall into the low-effort, low-control quadrant. Your data moves through external servers, and you are subject to the provider's recurring token pricing. Moving to on-premise infrastructure puts you in the high-control quadrant. By hosting open-weight models in your own private cloud, you retain absolute data sovereignty and move toward a flat operational cost, regardless of inference volume. Achieving that level of control requires a heavy upfront capital investment. You need to secure GPU clusters and maintain the internal MLOps talent required to keep them performant. This choice determines your long-term economic model. You are either renting compute power for a monthly fee or purchasing the hardware needed to control your own data. Above the hardware sits the routing layer, acting as a traffic controller between your application and your intelligence engines. AI gateways like OpenRouter or Light LLM consolidate multiple providers into a single API. They handle automatic fallbacks and can route requests to the cheapest available model that meets your requirements. In this feature matrix, we see that gateways prioritize flexibility. However, they do add a minor latency hop to every request and introduce an external dependency into your core pipeline. Alternatively, you can centralize routing within an enterprise platform like AWS Bedrock or Azure AI Studio. Because these platforms sit inside your existing cloud provider, they inherit your organization's current security configurations and compliance certifications like SOC 2 or HIPAA. The trade-off is cloud ecosystem lock-in. Deep integration with a specific provider's AI tools makes it more difficult and expensive to migrate your infrastructure in the future. Your routing choice balances agility against trust. Gateways allow you to switch providers quickly, while enterprise platforms simplify compliance at the cost of long-term flexibility. The intelligence layer is the reasoning engine itself. In the current market, no single model is the most efficient choice for every task. This comparison table shows the current performance landscape. Claude Opus 4.6 leads in graduate-level scientific reasoning and nuanced writing, scoring 87.4. However, its performance lead over competitors has narrowed recently, and independent public validation of its latest reasoning modes is still limited. Gemini 3.1 Pro provides a 2 million token context window at a significantly lower cost, though it typically misses the absolute peak reasoning scores seen in Claude or GPT. Model selection has shifted toward matching the specific cost per token of a model to the reasoning requirements of each specific task. The action layer provides the orchestration logic that allows these models to autonomously use tools and execute multi-step workflows. LangChain provides granular control over every prompt and retry strategy. This allows for precise customization, but requires significant engineering effort to manage the complex code-first architecture. If we map frameworks by learning curve and approach, CrewAI sits in the center. It uses intuitive, role-based delegation, though coordinating multiple specialized agents results in higher cumulative token usage per task. OpenClaw uses a configuration-first model. By defining agent behavior in Markdown files rather than code, you can deploy working automation faster, though you lose some fine-grained control. AutoGPT is designed for high autonomy goal-seeking. Without strict constraints, its recursive loops can lead to unintended token consumption that outpaces the value of the task. Framework selection dictates your engineering speed. Choosing a complex framework for a simple task can result in an API budget that exceeds your operational projections. An effective AI strategy requires matching these 4 layers directly to your primary business constraint. This decision tree outlines 3 paths. For strict compliance, pair on-premise deployments with LangChain. To manage high data volumes, use an AI gateway routing to Gemini 3.1 Pro. For rapid prototyping, combine a gateway with OpenClaw to minimize development time. Leading with your business constraints ensures that your infrastructure investments solve your actual technical and economic problems. Long-term institutional loyalty to a single model provider can become a bottleneck when more efficient models or cheaper infrastructure options emerge elsewhere. Because the underlying technical standards in AI are changing every few months, systems must be built to adapt to those changes without a complete rewrite. A 2026 AI strategy relies on a flexible architecture that allows you to swap out specific components the moment the market math shifts. In this environment, long-term efficiency is achieved by those who build modular systems, rather than those who rely on a single, monolithic provider.
Thank you for watching. For more professional AI insights, remember to like this video and subscribe to AI Corecast.